All right, so today what we're going to do is we're going to do a little bit of review and then have a little bit of some arithmetic sequences, but today what we're going to talk about for the most part is proportional and non-proportional. You have got to be able to identify if something is proportional or non-proportional based off of three different things. You need to be able to look at the equation of the line and tell me. You need to be able to look at the t-chart or t-graph, however they want to call that, and tell me if it's proportional or non-proportional. And you got to be able to look at a graph and tell me if it's proportional or non-proportional. So let's take a look at this. If something is proportional, one is going to have a constant rate of change. It's going to be linear. Okay, so that's the first thing. Has a constant rate of change. It's going to go through 0, 0. That's the big key right here, right? So it's going to have a constant rate of change. It's going to go through 0, 0. And it can be written as y equals kx. So this is what you're looking for whenever you look to see if something is proportional. If it doesn't fit this criteria, it's non-proportional. Everything else is non-proportional. Okay, so again, proportional has a constant rate of change, goes through 0, 0, the origin, and can be written as y equals kx. Okay, direct variation, right? So understand what you're looking for. Now let's look at a couple of examples here, right? So I have some examples here, kind of what you should be looking for. And I already worked out some stuff so that you can kind of see it. But let's start with the equation, right? If it's proportional, it's going to be written like this. It might also have this, f of x or y. It's going to be one of those two, equals kx. So this is y equals kx. Right? If it's non-proportional, notice your equation of your line over here. Y equals kx plus, oh, we have something extra off to the side here. All right? So now this right here is non-proportional. If it cannot be written like this, it's non-proportional. And that's what you should be looking at. Now, the next thing is your t-charts, right? So here, have some ordered pairs on there. Okay? And what you can do is, because if it's a direct variation or if it's proportional, okay, you can do k equals y over x. Well, that means that you're going to be able to find your k by putting y over x, and it's going to be the same all the way down. All right? So here, y over x has 3 over 1, which equals 3. Now notice, I can continue to do this, and I keep getting the same k all the way down, all right? And this is going to be your slope. When you're talking about y equals kx, this, the k, constant of variation, constant of proportionality, rate of change, slope, all the same thing, all right? So here, your slope, and I use the slope formula right here, equals 3. Notice, that's what this was. Okay, so when you're looking at if something's proportional, you can put y over x. It's going to get your k or your slope, and you're going to be able to find your slope using slope formula, and it's going to be the same. Okay, that's what it's looking like to be proportional. Now, if it's non-proportional, if you do y over x, you're not going to get your k. All right, look, y over x. 3 over 1, 3 over 1 equals 3. But no matter, as I do this, notice it's not the same. 1 over 3 gets me 1 over 3, 0 over 4 gets me 0. It's not the same all the way down. That tells me immediately this is non-proportional. And then look, I did my slope formula. I didn't get the same thing here. Now notice here, it was the same, but it wasn't the same all the way through. Okay, it's going to be the same all the way through when you have a proportion over here. So this t-chart is non-proportional. It doesn't work this way, right? So the other way that I said is that you need to be able to look at a graph. So we're going to look at a couple of graphs here, and then we're going to do some arithmetic sequences. All right. Notice I've got two graphs here, and they're both proportional. And the easy way to check is when you're looking at it, it goes through the origin. One, it's a straight line. It's got to be a straight line, okay? Because it's got to have that constant rate of change. So it's got a straight line, goes through 0, 0. And it's a real quick look if you have a graph. Now look, f of x equals 2x. That's the same as saying y equals 2x. That's written y equals kx, y equals kx. So we're good. We know this is a proportion. Same thing here. Straight line goes through 0, 0. Here's my equation just so that you can see it as the equation. But it's a nice straight line and it goes through the origin. This is proportional. Okay? Now down here, notice it doesn't go through the origin. This is non-proportional. And then if you look at your equation of your line, notice it has something extra added on over here. So I know this right here, non-proportional. Same thing over here. Okay? Your y-intercept doesn't go through 0, 0. That's the key. Okay? Straight line, but doesn't intersect our origin. Non-proportional. And then here's the equation of the line, 1/4 x plus 2. Got something extra over here. No, it's not proportional. All right, so now let's talk about some of the stuff that we haven't talked about. Now, this is adding on to what we did yesterday, and it's going to add on to the arithmetic sequences. When you're doing an arithmetic sequence, once you simplify the equation, right, because you're going to be putting this into the equation, you're going to simplify that equation, and you need to be able to look at it and go, that equation is proportional. And that's what we're looking at here. We want to be able to look at it and go, oh, this is a proportion. This sequence is proportional because it fits this y equals kx mold that we're looking for. Okay, so we're going to do two different examples. One of these is proportional, one of them's not, so that you can kind of see what's going on. All right, so use your formula. Okay, that's first. Okay, so here I need my first term. That's 1. Right? So an equals 1 plus parenthesis. I'm not going to do an nth term yet. N minus 1 parenthesis, and then what the difference is. Well, the difference is going up by 2, so I'm going to plug in a 2 there. Okay? Distribute this here and here. Okay? So you get this an equals 1 plus 2n minus 2, and then we're going to solve, okay, simplify. So 2n, or a to the n, equals 2n minus 1. Look, does that fit the mold of y equals kx? Well, here's your y equals kx, but notice it has this extra part over here, okay? This is non-proportional, okay? That's a non-proportional. It's got that extra little bit right there. That's really what you're looking at, because what they're going to ask you is something like this. Determine if the arithmetic sequence is a proportional function or not. That's what they're going to ask, okay? So this is what we're doing. We know this is non-proportional, so that probably means this one is. So let's plug it in. A to the nth term equals the first, -3, plus, parenthesis, n minus 1, parenthesis, and the difference. So it's going down by 3 each time. Okay? You're going to distribute this through here and here. So a to the nth equals -3 plus n, and -3 times -1 plus 3. Missed my -3 in there. Make sure you distribute correctly, that'll cause you problems. All right, so then combine our like terms, get you -3n plus 0. A to the nth equals -3n plus 0, but any number plus 0 gives you back that same number. So you have a to the nth equals -3n. Well, okay, y equals kx. Oh, that looks awful lot like a proportion, right? So it is proportional. It needs to fit this mold. That's what you're looking for. Okay? Make sure you distribute correctly. Make sure you have each term in the right spot. Make sure you recognize the difference, and you're going to be able to do this. Okay? Again, this is the equation. This is the equation. And if you look over here at these give you really good examples of what you're looking for proportional and non-proportional. If you have any questions, you need help, let me know.